Okay, so our next section in our rational functions unit is going to be multiplying and dividing rational expressions. So we're going to take these fractions and we're gonna multiply and divide them together. Okay, so again, use your guided notes. These notes should be printed out for you. They're over on the side of the room. Um, Write down your questions here as you go. If you have any questions, write them here, and I'll be around to kind of help you out as needed. So let's start off with the first thing. It just says simplify. So 20 over 24, right? We know that they're both divisible by 4. So if you divide 20 by 4, you get 5. And you divide 24 by 4, you get 6. So that would be a simplified version. Pretty easy stuff. We know how to do that. The next one is we're going to, you see how we get an x in the bottom. Now, let's actually detour a little bit. Let's jump down here to excluded values. I want to talk about that a little bit, and then we'll come back up to it because we'll cover excluded values as we go. So what is an excluded value? Well, it's a value um, that are just like left out. I guess I can't say or excluded because that's excluded. So left out. So values in which are left out of the function. So and why? Because they make the denominator 0. Okay, you don't want to make the denominator 0 because are we allowed to divide by 0? No. So if you were to look at this function right here, okay, this one right here, um, what value could not go in here? Well, 7 times what would be 0? Well, 7 times 0 would be 0. So x cannot equal 0 because if it did, you would be dividing by 0, which is not okay. But, alright, so that's the excluded value. Now, as far as what it would be simplified, these x's would cancel with each other, giving you 7 fours, or 4 sevens. Okay? We know how to do that. That's old news. Now, coming on over here, let's look at the excluded values for this problem. The excluded values here, x can't be 4, right? Because if it was, 4 minus 4 is 0, and x cannot be 4, and x can also not be negative 3 because that would make it a 0 in that section there too. Just in the denominator. I don't care about the top, just the bottom. So what's going to cancel in this problem? It's pretty clear to see if x and x canceled on the last one, x plus 3 and x plus 3 are going to cancel, leaving you with 4 over x minus 4. Pretty easy. Okay? All right, next problem. What can what would cancel in this case, right? You got a c on the top and a c on the bottom. So these two would cancel, giving you a over b, right? And we know that b can't be 0 and c actually cannot be 0 as well because they would make the denominator 0. Okay, this last one, this is a common mistake. I'm gonna just show it to you. A lot of people like to reduce this way when they look and they say, oh look, 2 and 4, they're both divisible by 2, and 3 and 9, they're both divisible by 3. Well, you can't do that. You can't just reduce it that way. It has to be something that the whole top is divisible by and the whole bottom. Okay, you can't just look at it and say, oh, I know 2 and 4 have something in common, and 3 and 9 have something in common. You got to look at that. So in this case, you're actually done. This won't simplify any further because there's nothing you can pull out to cancel, so it's done. As far as its excluded values, well, what would make this bottom 0? Well, 2x minus 9 equals 0, so 2x equals 9, and that would mean x equals 9 halves. So if you divide both sides by 2. So x cannot equal 9 halves. Otherwise, the bottom would be 0, and that wouldn't be okay. So that's excluded values. Excluded values pretty easy. Just can't make the denominator 0. All right, let's keep it going here. Let's look at this example. Simplify this expression. We're going to be doing a lot of factoring in this section because, well, that's what we do, a lot of factoring. So let's take a look at here. If you look at the bottom, this x squared minus 16, we know that can break down to an x plus 4 and an x minus 4. That's the difference of two squares. We've done that before. So this is that second quarter coming back into haunt us. It doesn't go away. So these two x's will cancel, and you would be left with just really a 1 over x minus 4, and that would be its simplified version. Now, its excluded values, we should have taken from here and here. So we know x cannot be 4 or negative 4. It can't be either one of those two because it would make it 0. So this is my simplified version. my simplified problem, and those are my restrictions. Okay, on this one, hard to see what values to exclude here. So what we're going to do is we're going to do a little bit of factoring. So if we take a look at this bottom, okay, this p squared minus 2p minus 24, and factor that, I think that breaks down. I'll do it quickly in my head. Let's see, p and p, 24, difference of 2, that's got to be 6 and 4, so we're going to go minus 6 plus 4. So more factoring, it doesn't go away. So there's your bottom. So your excluded values are pretty easy to see now. I know p cannot be negative 4 or 6, so that's taken care of. Now as far as simplifying, that doesn't cancel with anything on the top, so look for a GCF here, GCF. Okay, so my GCF, I got a 2p I can pull out. If I pull a 2p out, that leaves me with a p minus 6, p minus 6. Okay, well, isn't that nice? Something's going to cancel. That's what we want to happen. It looks like this and this are going to cancel, leaving you with 2p over p plus 4, and that's your final answer right there. Okay, so that would be simplified right there. Let's take a look at some multiplying. So next section down, multiplying. Remember, when you're multiplying fractions, it's straight across the top, straight across the bottom. That's what we're doing. But before you multiply that out, what you might want to do is see if things cancel, because oftentimes they do. Okay, so if we're looking at this, look at, let me get my highlighter out here. We got a 2 here and a 4 there. Those two will cancel, right? And we have an x here and an x here, so those two are going to cancel. So there's going to be a lot of canceling here. We know that this x is going to cancel with this x, or it could have canceled with the other x. And then this 2 will cancel with this 4, making this 2 a 1 and this 4 a 2. So I have a 2 there. Now let's look at the 9 and 3. We know 9 and 3 have some things in common. This would be a 1. This would be a 3, right? We got a y, which cancels with one of these y's. So there's really 2 y's left. And this x will cancel with one of these x's, only leaving one x there. So what do we really have here? I know it kind of gets a little lobbed up together, but you got 2 times 3, right, which is 6, and y times, well, there's 2 y's up top, so y squared, so 6y squared. And on the bottom, what do I have? I think I only have 1x. So there you go, you're done. That's about as far as it goes. So a lot of stuff canceled, not too hard. So let's cross cancel over here. Now, before you cross cancel, you need to factor some of this. So we got x plus 5, which will stay on top, he's fine. The bottom of this, if you go back to your factoring notes, it'll go x, got to get to 12, got to multiply to 12, add to 7. That's got to be 4 and 3. So plus 4, plus 3, and we're good. And then up top, there's a GCF of 3. So pull the 3 out, you get x plus 3 up top. On the bottom, that's difference of 2 squared, so x plus 5, x minus 5. These are all old stuff in the second quarter. Doesn't go away. Now let's start cross canceling. So let's see. This guy is going to cancel with this guy. That's nice. This guy can cancel with this guy. That's nice. And that's it, I think. So we're left with a 3 on top and an x plus 4 and an x minus 5 on the bottom. And that's it. That's as far as you can go. So a lot of factoring, and canceling is all you're doing. So let's take a look at this next one. This one doesn't have a bottom here, so that kind of throws some people off. We'll throw a bottom there. Put it over 1. Now it does. All right, so breaking it down, we got n minus 3 over there. This can pull out a GCF of a 2n, leaving you with a 2n plus 1 if you pull out the GCF. And up top, it looks like it should factor. Let's see. So you would go 2n. All right, so this is one of those ones where you might want to use the big X method, right? Big X. And you say 2 times 3 is 6, right? So you got a negative 6 up top, and you want to get to a negative 5. What will work here? It's going to have to be 6 and 1, so we'll go negative 6, negative 1, and then remember you divide by that leading coefficient, which is a 2. So, and then you reduce. So this expression right here is going to be negative 3 over 1, and this is negative 1 over 2. So what you can do is bottoms up. Remember bottoms up. So this gets the x, it comes right here, this goes right here. So you get an n minus 3 and a 2n minus 1. And that should multiply out, and it does. Are we good? Let's see, it's a minus 6, minus 1, n plus Oh, this should have been a plus. My bad. This should have been a plus. That should have been a plus. That was my fault. Sorry about that. And then that does work. So you get an n 2n plus 1 here and an n minus 3 there. Okay. And you know what? Oftentimes they will cancel. So that sometimes gives you a hint. So I had a little problem with the plus there, but there you go. These two cancel, and that's all you got. So you got an n minus 3 times an n minus 3 divided by 2n. You could also write that if you wanted to as n minus 3 squared divided by 2n. I would have been okay with the previous one as well, so either one would work. Okay, let's look at this one, dividing. So the rule for dividing fractions is you keep the first one alone and you flip this guy over. This guy gets flipped. So, and you multiply straight across. So it's going to be 3x divided by 5x squared, and then you're going to multiply this by the reciprocal. So 15 over 6x. You see how I switched it upside down? All right, now I go into canceling mode. So cancel, cancel. This is going to become a 2, and that goes away. This goes away, and this becomes a 3, because 15 over 5 is 3. And then that x squared has nobody to cancel with, so we're left with a 3 on the top, that's it. And on the bottom, we have 2x squared. And that's it. You're done. 2x squared. So that's it. Okay? Alright, so let's take a look at this over here. This one looks a little more complicated. It's not going to be that scary, though, because we know we just follow the rules. You just flip it over and then multiply, which becomes not too bad. So I want to actually flip this one and multiply this, and factor at the same time. M squared minus 4 is the same as M plus 4, M minus 4, and that is your difference of, oh, hold on, time out. M plus 2, M minus 2. That's your difference of 2 squares, right? That's that difference of 2 squares formula from factoring. And then the bottom is going to be 3 times m plus 5. Okay, let's see what cancels. All right. Well, it looks like these two are gone. It looks like, oh, this is tricky. You see this here? This is kind of a tricky problem. That guy can actually be manipulated. Let's say that we look at that as the same thing as negative m plus 2, right? That's the same thing. Well, what I could do is pull out a negative 1. If I pull a negative 1 out, I would have negative 1 times m minus 2, right? Yeah, m minus 2. So that would be the same thing. Now, hopefully you see it now, that this expression will cancel with this expression, leaving you with just the negative 1 on this side. So when you put it all together now, and then this one's a little bit confusing, you're going to have just your m plus 2 up top. That's the only thing left up top. That's that guy. And then on the bottom, all we have is this negative 1 times this 3. That gives us a negative 3. And then that's actually reduced. That's the best you could do on that one. Not too bad. Okay, that one was a little harder, but that wasn't too bad. Let's take a look at this one. So dividing again. Oh, but this is the problem because we don't see a fraction. Don't let that throw you off. We can put a fraction there. So go ahead and flip it over. So we'll have a y minus 4 divided by a y plus 5, and we're going to multiply that by 1 over. Why don't we factor this at the same time, because we know we're going to have to factor. Lots of factoring fun in this section. Lots of factoring, which is hopefully, we've been doing it for a long time. Hopefully we're getting good. Let's go y and a y. 36 to get to 5. That's got to be 9 and 4, right? So 9, 4, plus 9, minus 4. Let's see what cancels. Oh, well, look at that. Isn't that pretty? Those are gone. And that is all I could see that cancels. So you're left with 1 over y plus 5 times y plus 9, and that would be it. That would be all you can do for that problem. Complex fractions. Let's take a look at this one. This one can get a little ugly, but it's not that bad. I like to rewrite these as this way, because sometimes it helps people to see. Now you just flip and multiply. So this expression is just going to be a third times 4 thirds, right? Because I flipped this guy over. This guy got the flipper root. So when you're done here, you get 4 over 9, 4 ninths. Okay, so not too bad. Let's jump over to this next one. We got some x's in here, but we're not scared. That's going to be x over 4 times. Now, this guy would normally come up, but I'm going to go ahead and flip them at the same time. Hopefully you follow this. This is going to be a 5 over 2x because I flipped it. So here we go. What's going to cancel? These x's are going to cancel. And you're going to be left with 5 over 8. And that's about all you got there. Let's take a look at this one down here. We got an expression. Ooh, this is kind of ugly looking one here. Why don't we write this one out? This one's got, this is pretty. Okay, so divided by x squared minus 4. I'll show all the steps on this one. This one's nasty. All right, so now I would flip it. Flip the second guy. Okay, so first guy stays the same. Second guy gets flipped. So we get 9 over x squared minus 4. And hopefully you looked at that x squared minus 4 and like, whoa, yeah, that's difference 2 squared. So I know you were thinking that. You beat me to it. So there you go. Let's go ahead and factor that. That's going to be x plus 2, x minus 2. Sorry, I need my coffee. All right, so now these two cancel. Boom, boom, gone. 3 and 9, that'll make this guy a 3. So you're left with really just a 3 over x minus 2, and that's it. That's not as bad as it looked. Okay, this one's nice. You're going to like this one. Okay, so 3 over 4x times, let's go 4x over 5. Okay, so because remember, you did the flip. I flipped on the bottom. Well, you're going to see that these 4x's cancel, leaving you with 3 over 5. That's a nice, easy one. Not too bad. Okay? All right, now, this next section where it says try it, I want you to try this on your own. So I'm going to pause the video. All right? So I'm going to stop the video right here. You're going to hit the pause button. You're going to try these problems yourself. Okay? And then when you're done, check them to see if you got the right answer. Okay? Okay, so... Okay, and we're back. So hopefully you did pretty good. You can check over your answers real quick, see if you got it right. If you got them right, go ahead and move right on to the practice exercises. If you didn't, let's follow along and see what you did wrong. So on this first one, hopefully you looked at this and said, okay, I know that this bottom right here would move over to factoring out a GCF of 2, giving you x squared minus 25. You know that's a difference of 2 squares, so that's x plus 5, x minus 5. And hopefully you see these green marks here. The plus 5 and the plus 5 cancel, leaving you with only a 2 and a, this 2 and this x minus 5 for your bottom. And for your top, all you got is an x, and that's it. So hopefully you did good on that. If not, we'll fill you in. Next one. So this bottom part right here factored. It factored into these two expressions. The top had a GCF of x. You pulled the x out, you had an x squared minus 9. That's this line right here. So then what you did from here is you knew that was difference 2 squares, so that's x plus 3, x minus 3, that's right here. Okay, and then you started canceling. So I looked at it and said, okay, here, we'll switch to a green highlighter. I got an x minus 3 here and x minus 3 there. I got an x right here and I got an x right there. That's only going to leave you with a 2 and an x minus 10 on the bottom, and on the top, you're going to have an x minus 7 and an x plus 3. Hopefully you did pretty good on that. I just noticed something. I forgot my excluded values for the previous one. Why don't we fill that in real quick? My excluded values for this problem right here, that was my bad, I forgot that, is going to be x can't be -5 or 5. It can't be either one of those. If it was, we would have a 0 in the denominator. So it can't be that. Okay, jumping down to this problem right here, let's see what we got. If you flip it over and multiply, you know this 4 and this 20 is going to cancel, giving you a 5. And then you got a y squared on the bottom and a y here. So those are going to cancel with one of the y's on the bottom. And then you know the 5 and the 5 is going to cancel. That's not leaving you much. That's only leaving you with a 3 on the top and a y on the bottom. That's it. Now this far one looks kind of hairy, but it's not too bad. Go ahead and flip that bottom over and get it set up. Factor out a GCF of 3 right here. It leaves you with an x plus 3. Now you got an x plus 3 on the top and the bottom, so these two are going to cancel. They're gone. You got a 4 here and an 8 there, which means this 8 is going to become a 2, and that 4 is gone. So now you're left with just one x on the bottom, which is this guy right here, one x on the bottom, and you're left with a 2 times a 3, which gives you 6. So you got 6 over x, and that's it. So you're just about done. Why don't you go ahead and summarize what you saw? That's on the bottom. That's a good idea. If you got any questions, make sure you ask them. And that's all we got for the second lesson. Good luck on the practice exercises. We'll see you in the master check.